Hello and welcome to this course on FEM for CFD and Multiphysics. I am Jaideep. I am a chemical engineer. Primarily I am an experimentalist, though I have been using coding since a decade to understand my experiments better, and a lot of this has involved coding CFD from scratch. I am also an entrepreneur, and my company works in reaction engineering and pharmaceuticals oriented business. Since the last 5 years, my company has helped my clients to put multiple FDA approved products on the market shelf by leveraging the technology that we have made. So computer-aided engineering tools have been a solid companion in all of my work, and indeed these tools are now used not just by engineers but by all kinds of STEM professionals, whether you are a microbiologist, whether you are a designer, a geologist, a chemist, right, experimentalist. So everybody is using these tools, and that's because all of the wealth creation now lies at the interfaces of science. Okay, and this is where you can see softwares like COMSOL Multiphysics or Phoenix really flourishing. That is because finite elements are really good at simulating multiphysics problems. So really my motivation here was to make finite elements accessible to as many STEM undergraduates and graduates. That is because the finite elements comes from a mathematical background and a solid mechanics background. So there are a lot of courses from that angle. But if you are a chemist or biologist who has just done basic undergraduate level math, so there is a dearth of courses. So I aim to make this course which is accessible to basically all kinds of STEM students. So basic requirements are the basics of differential equations and calculus, basics of vectors and matrix algebra. So these have to be known, but only up to the undergraduate math level. And this is the course structure. So we want to approach FEM quickly since this is a crash course. So the idea is to start off with FDM basics, and where we will understand discretization, error analysis, and some of the basic concepts related to CAE. And then we'll go to FEM and conservation statements, which will shed some more light over the transport CFD kind of problems. And then finally, we'll understand FEM through a series of lectures. I will explain the physical relevance of the two test cases which we have taken, Poisson equation and convection diffusion equation, and we'll be solving this on an Excel sheet. And I have used the spreadsheet format because it is really accessible and you can see all the changes in the data structures in real time when you use an Excel sheet. But a bonus content of a 1D code in Julia, which is a high performance computing language, free language, and MATLAB will also be provided, but that is an optional part. So this is what I wanted to talk about in this basic intro. I would leave you with these two books which are really fantastic for primary education in this field. And this is going to be a free course. Please make the most of it. Please give me your feedback and help me make finite elements more accessible. So I thank you for your attention, and now I'll see you in the actual theory lectures.